Good day everyone and welcome back to DepEd TV. I am Teacher Joshua and I will be your guide in sharpening your skills and enhancing your minds in order to face the challenges in Grade 8 Mathematics. Ready your self-learning module, your paper, and your pens with you, and let us have a wonderful day of solving problems involving factors of polynomials. Have you been in a farm? The Philippines is an archipelago located in Southeast Asia, and even though it is surrounded by bodies of water, it is also known for its agricultural land. Let's take a look at this farmland. Mr. Pedro knows the area of this farm. Knowing the area, can we help him find out the dimensions of the land he is farming? This kind of problem is usually answered by applying our knowledge in factoring. Do you still remember our lessons regarding factoring polynomials? Let's have a review. Match the following polynomials to their respective factored form by placing the flowers on the correct pots. Let us start with this one. A squared minus 4ab minus 45b squared. What is its factored form? The answer is the quantity a minus 9b times the quantity a plus 5b. What we factored is a general trinomial. Next, factor 18ab squared minus 12ab. It is 6ab times the quantity 3b minus 2. We factored this polynomial by getting the greatest common monomial factor. How about 49a squared minus 25b squared? This is a difference of two squares, and it is a product of 7a minus 5b and 7a plus 5b. Let us have a squared minus 18ab plus 81b squared. What type of polynomial is this? It is a perfect square trinomial, and its factored form is just the square of the quantity of a minus 9b. How about the last two polynomials? These are the sum of two cubes and the difference of two cubes. And the signs of their factors depend on the operation they used in the special product. These are the polynomials we had factored in the past few lessons. That would come in handy as we solve some examples of problem solving. Now look at this small vegetable garden. What is the shape? Its shape is a square. And the area of that square garden is 9y squared plus 30y plus 25 square meters. What polynomial expression represents the measure of each edge? There are many ways to solve a problem, and doing it step by step is one helpful strategy in tackling this. Let us identify what is given. First, the problem states that the garden has a square area and it measures 9y squared plus 30y plus 25 square meters. Next, what is asked? We are asked to find the measure or length of the edge. Now, we analyze what we have and what we need in order to solve this problem. How can we get the length of the edge with the area of the square garden? What do we know about the area of the square? The area of the square is just the side multiplied to itself, or s squared. How about the given polynomial? What did you notice? It has three terms. What else? The polynomial is also a perfect square trinomial. so it can be expressed as a square of a binomial, and that binomial is the answer to the problem. A perfect square trinomial can be factored by expressing the first and the last terms as squares of other expressions. What is 9y squared equal to? 9y squared is the square of 3y. How about 25? 25 is 5 squared. Let us then double check if the trinomial is a perfect square by getting the product of those expressions and multiplying it by 2. What is 2 times 3y times 5? That product is 30y, which is equal to the middle term. After proving that this is a perfect square trinomial, we can solve for the length of the side of the square using the area. 9y squared plus 30y plus 25 is equal to the square of what binomial? The square of 3y plus 5. So how long is the edge of the vegetable garden? It is represented by 3y plus 5 meters. The most common problems that involve factoring are about the area or volume of figures. Now, can you see what is behind the vegetable garden? It is a fish pond. But wait, there are also materials here that can be used for construction. We can create a walkway around the pond, and we can also use factoring in this situation. The pond is a square and has an area of 64 square feet. What will the area of the walkway be if we want it to be 2.5 feet wide? We can visualize the problem like this. We have a square pond that has an area of 64 square feet. With that, how long is each side of the pond? Each side of the square pond measures 8 feet. Now, we want to have a walkway around the pond that is 2.5 feet wide. Observe that we made a bigger square. If the side of the smaller square is 8 feet, how long is the walkway in each side? We add 2.5 or 2.5 feet to the left and another 2.5 feet to the right, and we will get a total length of 13 feet. We just need the area of the walkway, so we do not need to cover the pond. What type of special product best describes this situation? It is a difference of two squares. Note that the area of the walkway will be given by the square of its side, 13 squared, minus the square of the side of the pond, 8 squared. We do not need to evaluate the numerical expressions, since we can show this by factoring. How can we factor 13 squared minus 8 squared? Since this is a difference of two squares, we can write this as the quantity of 13 plus 8 times the quantity of 13 minus 8. Let us simplify the expressions inside. What is the sum and the difference of 13 and 8? 13 plus 8 is 21, and the difference is 5. Last step is to multiply the numbers 21 and 5. The product in the area of the walkway to be constructed is 105 square feet. Look! This fish pond is actually connected to the irrigation trough for our garden. It can supply and regulate water for the plants. The trough is the shape of a rectangular prism, and it can contain a volume up to x cubed plus 64 cubic inches of water. What kind of polynomial is this? This is a sum of two cubes, and it can be written as a product of a binomial and a trinomial. In this case, the The binomial factor represents the height of the trough, while the trinomial factor is its base area. What is the base area of the rectangular trough? The volume of a rectangular prism is given by multiplying the height by the base area of the figure. And to solve this problem, we can start with the given x cubed plus 64. Since this is a sum of two cubes, the polynomial can be factored by expressing each term into cubes of certain expressions. X cubed is just the cube of x, and 64 is the cube of which number? It is 4. And since this is a sum of two cubes, the binomial factor is x plus 4. This is the height of our trough. Now, let us solve for the base area by finding the trinomial factor of this polynomial. We get the base area by squaring the first term of the binomial, x squared. Next, what operation should be here? Addition or subtraction? The first operation in the trinomial factor must be opposite of the binomial. So given that the binomial factor shows a plus sign, this must be a minus sign. Then multiply the terms x and 4. We will get 4x. The last sign is always positive or a plus. And the last term is the square of 4. 4 squared is 16. Now that we have factored x cubed plus 64, what is the base area of the trough? The trough has a base area of x squared minus 4x plus 16 square inches. Agriculture do not only include plants and crops. It also involves livestock or produce from animals like eggs from chickens or poultry. For example, we use or make egg cartons considering the size, the weight, and the number of eggs to be put inside to have efficiency in collection. Let us say that the area of the rectangular egg cartons that this farm use is 15x squared minus 13x plus 2 square inches. Find the polynomials that represent the dimensions of the rectangular egg carton. We are given a polynomial with 3 terms. It is a trinomial. But is it a perfect square? No, it is not. So this is a general trinomial. The area of a rectangle is equal to the product of its length and width. And we are asked to find its dimensions. So we just factor the given general trinomial. When factoring the general trinomial, we identify the first, the middle, and the last terms with their corresponding signs. The first term is 15x squared. The middle is negative 13x. And the last term is positive 2. Then we multiply the first and the last terms. What is the product of 15x squared and 2? It is 30x squared. Next is we will find factors of 30x squared whose sum is equal to the middle term with its sign, negative 13x. Can you give me factors of 30x squared? Since the sum of the factors should be negative, let us try negative 5x and negative 6x since their product is 30x squared. Now, get their sum. What is negative 5x plus negative 6x? It is negative 11x. Not the same with the middle term. It means that we got the wrong factors. Can you think of other factors of 30x squared? Let us have negative 10x and negative 3x. Can you add these two expressions? Their sum is negative 13x. It means that we got the correct factors. Now, let us rewrite the given polynomial with the first and the last term together with the factors we acquired. 15x squared minus 10x minus 3x, since the factors are both negative, plus 2. Now factor the terms by grouping. How can you factor 15x squared minus 10x? They have a common factor of 5x. Divide 15x squared minus 10x by the greatest common factor to get the other one. So we will have 5x times the quantity 3x minus 2. How about the other pair of terms? Do they have a common factor? The common factor is negative 1. So we can write this as minus 1 times the binomial 3x minus 2. Now, can you give me the factored form of 15x squared minus 13x plus 2? It is equal to the quantity of 5x minus 1 times the quantity of 3x minus 2. Therefore, the dimensions of the egg cartons measure the quantity 5x minus 1 inches by the quantity 3x minus 2 inches. And that's it for today. We are finished with today's lesson on problems involving factors of polynomials. Whenever you are given a word problem, read, then analyze. Think about what prior knowledge you can apply to solve the problem. And remember to always write your answer in a complete sentence with the correct label or unit. And now that we finished the first chapter of your grade 8 mathematics, let us evaluate what you have learned by answering this short assessment. Prepare your pens and your paper, and I will give you 5 seconds to answer each question. Choose the letter of the correct answer. Number 1. Which expression represents the length of the side of the square with an area of 4b squared plus 16b plus 16 square units? Is it A, 2b plus 4 units, B, 4b plus 2 units, C, 8b plus 4 units, or D, 4b plus 8 units? The correct answer is letter A, 2b plus 4 units. Number 2, a rectangular garden has an area of 12x squared minus 8x minus 15 square meters. Find its dimensions. Is it A, 3x minus 5 meters by 4x plus 3 meters? Letter B, 6x plus 5 meters by 2x minus 3 meters. Letter C, 6x minus 3 meters by 2x minus 5 meters. Or D, 12x minus 15 meters by x plus 1 meters. The dimensions are given by letter B, 6x plus 5 meters by 2x minus 3 meters. Number 3, if the area of the square is 4x squared minus 4x plus 1, what is the length of the side? Is it letter A, negative 2x plus 2? Letter B, negative x plus 1? C, 2x minus 1, or D, x plus 2? The correct answer is letter C. The side measures 2x minus 1. How was the activity? Solving word problems is one of the skills we must develop to really test our knowledge about the topic. Just keep on practicing on the examples and assessment found on your self-learning modules. Remember that in mathematics, practice makes you better. For our next episode, read about our next lesson, Rational Algebraic Expressions. I hope that you have learned a lot in our episode today. Note that there are many ways to solve a problem, and you must focus on the patterns you have observed and process in factoring these polynomials. With practice and determination, I believe that you can ace any lesson in mathematics. Ready yourselves with a brand new topic for our next episode, and we will be illustrating rational algebraic expressions. Remember, math is not only about numbers and operations. It is an exercise for our minds, for us to be critical, logical, and responsible thinkers. Again, this is Teacher Joshua reminding you to keep safe, have a nice day, and see you next time.